So I'm trying to make two videos in one night because I'm going to be occupied at the game tomorrow. Um, you're probably watching this on a Wednesday night, so it means the game that was played last night. Um, and I'm making this video on a Monday, and this is definitely Monday because I have had a time with trying to get this done. My first video, I just realized as I started the second one that I didn't have the camera on at all. So there will be no video on that except for my screen, and hopefully the audio picked up. I haven't even looked at it. I may have to redo that video altogether. Um, what a day. Anyway, so the previous notes we talked about simple random sampling. Now we're moving on to other sampling designs that build off of simple random sampling. And we're going to just jump right into the first one, which is systematic random sampling. Systematic random sampling is quite simple in that there's a little bit less effort required to implement it than there is with just the general simple random sampling we looked at before. If we look at the steps of systematic random sampling, you can see there's only 3 steps. Step 1, we divide the population size by the sample size that we want to obtain, and then we round down to the nearest whole number, and that gives us some number that we're going to call M. For step 2, we use a random number table. Maybe we can use Excel or we can use our calculator, and we generate a single number that we call K that's somewhere between 1 and M. I really highly suggest that you make sure you use a random number generator or a random number table, not just arbitrarily pick some number out off the top of your head, because that does skew the randomness of the study. Then for part 3 or step 3, this is where we generate our sample. Our first member of the sample set is whatever that number K is, and then our subsequent numbers are K plus M, K plus 2M, K plus 3M, and so on until we generate an entire sample of the size we're looking for. And we're going to go back and revisit the problem of the professor that wanted to sample 15 of the 728 students in their college algebra class, and we're going to use systematic random sampling to do that. Remember when we did it on the last set of notes, we used the random number table. We had to pick a point on the table, and then we went down and up until we had an entire sample set. I think you'll see why this method is a little bit easier to implement. So for step 1, we take our sample or our population size, which is 728, and we divide that by 15. I've already typed that in on the calculator and it's 48 point something, but remember we're rounding down, so we get 48 is our value for M. So that's step 1. Step 2 is to generate a random number between 1 and 48. So if we go to our calculator, let's see, let's go, we type in RANDINT, and we put 1 comma 48. That's our lower bound and our upper bound, and we put another comma, and we only want one number, so we get the number 35. So then we go back to our steps here. So step 2, we get K is equal to 35. Step 3 is to generate the sample set. Looking at step 3 in the red box above, you can see that we select the sample for those members of the population that are numbered K. So K is our first member of the sample, so that person is numbered 35. And then we just add 48 to that to get the second person. So 35 plus 48 is 83. We add 48 to that and we get 131. We add 48 to that, we get 179. And we keep going until we get 15 people that are numbered somewhere between 1 and 728 to generate our sample set. Now just kind of a little aside here. Let's say that our 12th person happened to be numbered 720. So there's our 12th person. We still need numbers 13, 14, and 15. But when I add 48 to 720, I get 768. And 768 exceeds our upper bound on the population, which happens to be 728. So in a case like this, when you finally get to a point where you've exceeded the population size, you just take that very last number that is larger than the population set itself, and you subtract the size of the population from that number. And in this case, we get 40. So 40 would be the 13th person in the set. Then we add 48 to that, and we get 88. So now we have the 14th person, and we would add 48 to that, and we get 136, and there's our 15th person. So we started out at 35, and just hypothetically, our 12th person might be end up being 720. So then the way we get 13, 14, and 15 is by starting back over through simply subtracting the population size from the first number that is generated larger than our population. The next method of sampling is called cluster sampling, and you can see on here this is what we use when the members of the population are widely scattered geographically. So if they're spread out, they do appear in little groups, so it might be beneficial to do a cluster sampling of the population. I mentioned in class on Monday that we could consider our classroom a cluster of the population of Perry Central High School. Of course, that's only true if every classroom in the building is of the same size. So let's just say, for the sake of argument, we have 35 people in room 206 during first period. So if every classroom in Perry Central High School had 35 students in there during first period, each room is an individual cluster of the entire population of the school. So the steps for cluster sampling are: we divide the population into groups or clusters. So like I said, our classroom could be considered a cluster. We would obtain a simple random sample of those clusters. So if we have 20 clusters, maybe we need 5 of those clusters. We would sample those 5 clusters. That would give us our sample set. And again, this is going to be one of those that might be easier to understand with just a concrete example, and then we'll put it into practice with a practical application. So what we're looking at here on example 2, the 300 members of a population have been divided into clusters of equal size 20. Use cluster sampling to obtain a sample size of 60. Step 1 of cluster sampling says we divide the population into groups or clusters. Well, we already know the population size is 30. We know the cluster sizes are going to be of 20 people. So we need to figure out how many clusters we're going to have. So we take the population size divided by the cluster size, and we get 15. So we're going to have 15 clusters of 20 people each. I'm not going to label all 15 clusters, but we take cluster number 1 and we number the people in that group 1 to 20. Then we take cluster number 2 and we number the people in that group 21 to 40. Cluster 3 is 41 to 60. And we keep doing that until we get to cluster number 15, and everybody is numbered in that group 281 to 300. So there we've taken our clusters and we've broken everybody down, and we've numbered everybody in the population based upon which cluster they're in. The next step is to obtain a random sample of those 15 clusters. Now we want a sample size of 60. So we need to know how many clusters we want to sample. So we take our sample size divided by the size of each cluster, and we get 3. So I want to sample 3 clusters. So we use a random number generator. So I'm going to use this again, RANDINT, and I'm going from 1 to 15, and I want 3 clusters. So I'm going to sample clusters 1, 7, and 5 for this particular study. And that's going to work out nicely because I've randomly selected the groups of people, and all 3 groups contain 20 people, so that gives me my sample size of 60. And that's just numerically how you would go about creating a cluster sample. So when we move on and we put this into practice, we start out introducing this problem here where we're talking about several years ago, a citizens group in Tempe, Arizona wanted to install bike paths. So before they went through with it, the city planners wanted to find out whether or not there was enough people who supported the idea uh, before they started spending taxpayer money to put in these bike paths. So what they did initially was send out surveys with everybody's water bill. Well, what they found was that the 18,000 surveys that they sent out, only 19.4% of those surveys were returned. I know if anybody's like me, if I get my water bill, I'm already aggravated because I got to pay money to somebody. Two, if I see a survey on it, if that survey does not interest me, I'm just going to throw it away. And that's what they found in Tempe, Arizona when they did this. 19.4% of the questionnaires made their way back to the city council. And the majority of those that were returned were in favor of the bike path. Because, again, if it were me and I really wanted to have a bike path in my hometown, I would definitely respond to that survey and I would say, yes, I absolutely want this bike path, and I would send it back. If I was indifferent, I would just throw the questionnaire away and I wouldn't worry about it. And if I was adamantly opposed, then I would probably respond as well. So that's what they ended up with. They had a majority of people who were saying yes, they wanted this, but they also, these people indicated on their surveys that they were avid cyclists. They loved getting out riding their bikes. The people who were against it were adamantly against it because they were opposed to having their tax money spent on a bike path, but there were still just not enough surveys returned for them to get a good grasp on what the general feel of the entire population was. So they did have a person in their planning department who had a little bit of a statistical background, and she sat down and came up with a plan to get a more accurate representation of the population in Tempe, Arizona. So what she decided to do was cluster sampling, and initially she had two assistants, and so they needed to come up with 300 homeowners to interview for the project. So what they decided they tried or they thought about was just dividing everybody up, and then they found that if they did that, if they gave everybody 100 people to interview, and they did random sampling, simple random sampling, everybody was spread out. It would take almost 30 hours of driving time per employee to do this, and it wasn't going to be that cost effective. So they reconsidered their options and they came up with cluster sampling. So keep in mind we have three people that are going to be conducting these surveys. We want we have a city with residential size of 947 residential blocks. So we have our clusters. There's 947 clusters. Each cluster has 20 homes, and they want to get a sample of 300 homes. So we already know we have 947 blocks, which are our clusters. And we need to obtain a sample of 300 homes. Well, each block contains 20 homes. So we take 300 divided by 20 and we get 15. So they want to sample 15 city blocks to generate their sample population. So what we need to do now is if we just number all of our city blocks 1 through 947, we want to come up with 15 of those to go out and sample. So we go to our calculator and we will generate a random number or random numbers. So we do rand int 1 through 947 and we want 15 of those. So when we hit enter, I typed something in wrong. There we go, rand int. And here are our numbers. So we would look at whatever city block was numbered 921, city block 928, 794, 586, 195, 933, and we could go down that list. But what they ended up doing is those three employees took 5 blocks. And they would obviously take 5 blocks that are relatively close to one another. They would go interview the 20 homes in those 5 blocks, come back, compile their data, and then they would know whether or not they want to install the bike paths in the city of Tempe, Arizona. Back to the notes. Stratified sampling. So stratified sampling is another method, and sometimes it's a little bit more reliable than cluster sampling. In stratified sampling, the population is divided into subpopulations. That's the first step, and those are called strata. And then sampling is done in each stratum. And ideally, the members of each stratum should be a homogeneous relative to the characteristic under consideration. A lot of words, it'll make sense, I promise. So the steps for stratified random sampling. Step 1, we divide the population into subpopulations. Step 2, we obtain a simple random sample size proportional to the size of the stratum. And then step 3, we use all those members to generate our sample. Again, a numeric, concrete example, probably best, and then we'll go from there and come up with a more practical application problem. Okay, so this one's already kind of broken down for us. We have 2,000 people in the population. They're already broken up into strata sizes of 400, 600, 800, and 200. So we have 4 strata that we're looking at. And what we want to do is we want to use the stratified sampling method. So step 1's already done for us. They're divided into the subpopulations. And then we need to obtain a simple random sample proportional to the size of each stratum. So if we took the group with 400 people, we would number them 1 to 400. Then we would take the group of 600 people, and we would number them 401 to 1,000. We would take the group of 800, and we would number them 1,001 to 1,800. And then our last group of 200, we would number 1,801 to 2,000. So each person in the population has been given a number. So to do the step 2, to find the simple random sample size for each one of these stratums, we would take let me change color here. So this is step 2. The total sample size times the stratum size divided by the population. So for the group of 400 people, we do want a sample size of 10. So for the group of 400, we're going to have 10 times 400 over 2,000. And when we simplify that, we end up with a sample size of 2. That's from that group. And then we would do that for the group of 600. It'd be 10 times 600 over 2,000. And we would get 3. Then we would do the same thing for the group of 800. So it's 10 times 800 over 2,000. And we get 4. And then we have 10 times 200 over 2,000. And we get 1. So from the group of 400, we need 2 people. From the group of 600, we need 3. From the group of 800, we need 4. And from the group of 200, we need 1. And if you add these up, 2 plus 3 is 5, plus 4 is 9, plus 1 is 10. That gives us our 10-person sample size. So we can do a random number table, random number generator for each individual stratum. I'm not going to do all of them. I'll do the first one though. We need 2 people from the group of 400. So we would just do the same thing that we've been doing, RANDINT, and we need from 1 to 400, and we need 2 people. So we would interview persons numbered 254 and person 125. Real quick, I will do the second stratum. It's RANDINT. And on that one, our lower bound is 401. Our upper bound is 1,000. And we needed, I think, 3 people. So, comma 3. And so out of that third or that second stratum, we would select the individuals numbered 452, 999, and 519 to come up with our sample set from that group. We would continue that for the other two groups, put all those together, and there's our sample set. All right, so our last example, we have, it was mentioned earlier that we had a town that had they were wanting to put in a swimming pool. So the town has 250 homeowners with 25 people, 175 and 50, and those are our stratum. 25 people are in the upper income category. The 175 people are in the middle income category, and the 50 people are low income. So now we can get a sample of 20 homeowners using stratified sampling to come up with the group that we want to survey to find out whether or not these people want to put in a pool. So let's just go through this real quick. We have group number 1 has 25 people, so we number everybody 1 through 25. Group number 2 has 175 people, so we number them 26 through 200. And then group 3 has 50 people, and we number them 201 to 250. So we have our upper income group, middle income group, and lower income group. So we want to come up with a stratified sampling method for this. Our sample size is 20. So for our upper income group, it's 20 times 25 over 250. And that's going to give us a sample size of 2. When we look at our middle income group, it's 20 times 175 over 250, and we get 14. And then our lower income group is 20 times 50 over 250, and we get 4. So 2 plus 14 plus 4 is 20, and we would do the same process. We would do a random numbered table. We would find 2 people from the individuals numbered 1 through 25. So 1 through 25, we want 2 people. So we're going to interview persons 10 and 3. From the middle income group, we want 14 people, and they are numbered 26 through 200. So we do the same thing again, RANDINT, 26 through 200, and we want 14 of those. And so we would go through that list and pick those 14 people, and then we do the same thing for our 4 people, or 6 people rather, from the low income group. And this gives us a better representation and a more proportional representation of the entire population without actually having to go out and interview everybody in the town. All right, so in those examples, it worked out that every time we did the calculation for the stratum sample size, we had whole numbers. We had 2, 14, and 4 in that last example. But that's not always the case. Sometimes we'll end up with decimal values. So we have to use our better judgment. Do we round the stratum down? Do we round it up? Do what you want to do, but just make sure that your sample size is the size you're looking for. For example, suppose the population size is 100 and the sample size is 10. We have these strata of 26, 47, and 27. If we did the calculations, we would end up with sample sizes of 2.6, 4.7, and 2.7. If we rounded those, we get 3, 5, and 3. 3 plus 5 plus 3 is 11. That's one more than we want in our sample size. So what we could do is maybe round up the 2 that are closest to their rounded values. So 4.7 and 2.7 we round up to 4 and 3. The 2.6 we round down to 2. And now we have, 5 and 3. And then we have our 2. So there's our samples that we use. So that's where you just have to use your better judgment as far as the rounding goes. But the process is still the same. That is the end of this set of notes. There's your homework problems. So there is actually going to be a little bit of math in these, finally. We're going to start getting into more and more math. You may love it, you may hate it, but I promise you that it will benefit you. And I hope everybody has a great night, and I will see you in the morning.